Here is your review for your rationals test. Okay, so the first thing we're going to do is use Descartes' rule of signs to give the possible number of positive and negative real zeros. Okay, so like, why is this even going to help us? When we come up with all those possibilities and have to do synthetic division, then this tells us how many positive and negative possibilities we have, so we're not wasting our time with testing things. This is super easy to do. First of all, when you look at f of x, you look at the sign changes. So these have to be written in order, which they are. We change from negative to positive, then it stays positive, positive to negative, stays negative. So that means that my positive possibilities are 2 or 0, because it's always that number, the number of changes, and then or less than that by an even number. So then we have to find f of negative x. Well, when I substitute in negative x, anything with an odd exponent is going to change signs. Everything else stays the same. So I get x to the 5th minus 18x cubed plus 6x squared plus 5x minus 4. Okay, so then I can look for my negative possibilities. So I'm positive, change to negative, negative, change to positive, 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 change to negative. So that means that's 3 or 1, because it's less than that by an even number. So on this next one, positive, positive, change to negative, change to positive, change to negative. So my positive possibilities are 3 or 1. Then when I find f of negative x, give me x to the 4th minus 7x cubed minus 9x squared minus x minus 2. So it's positive, changes to negative, stays negative, 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 negative. So my negative possibilities here are just 1. All right, so then here, I'm going to write my polynomial function. I've got a 0, a negative 1 with a multiplicity of 2, and then 4/3. So when I write this with my factors, that means that f of x is going to equal, well, if my 0 is 0, I get x. And then this is going to give me x plus 1, but it's squared, because it's multiplicity of 2, times, and then remember that this is like x equals 4/3, so that would give me 3x equals 4, so 3x minus 4 equals 0. That's what this is, 3x minus 4. I don't just plop in that 4/3 there. And then I'm going to multiply. So what I'm going to do here, come back over here, I'm going to go ahead and square this. This x I'm going to multiply by this one over here, but I'm going to square this first. This is going to give me x squared plus 2x plus 1 times, and then x times 3x minus 4 is going to be 3x squared minus 4x. All right, so then I'm going to distribute. And I'm going to get x squared, and I'll multiply by both of these. So this is going to give me 3x to the 4th minus 4x cubed. 2x times both of these. It's going to be plus 6x cubed minus 8x squared. Then this times both of these, plus 3x squared minus 4x. Then I clean all that up, and that's going to give me 3x to the 4th. So I use that one. Got these two cubes, so that's going to give me plus 2x cubed, these two squared, so minus 5x squared, and then minus 4x. That is my possible polynomial. All right, so then this one here. I got x plus 5, x minus 5, so f of x equals, so we get x plus 5 times x minus 5, and then x plus 3 square root of 2 times x minus 3 square root of 2. So these are two difference of squares. So x plus 5 times x minus 5 is x squared minus 25. And these are in parentheses because I'm going to have to multiply again. There was a lot of you on the quiz that multiplied this, but then added everything together, which makes no sense. Then here, this is also a difference of squares. So I'm going to get x squared, and then I have to do 3 square root of 2 squared. So when you do that, you square both of them. So this will be 9 times 2, which is going to give me 18. It's minus 18. Okay, so it looks like that. Then I'm going to FOIL. So this gives me x to the 4th then minus 18x squared minus 25x squared. And then I have to multiply 18 times 25. So think about having 18 quarters. Like if you had quarters set out, 18 quarters, and you want to figure out how much money you have, you put them in little stacks of 4, right? So it's going to give me 4 stacks of 4 with 2 left over. So that's $4.50. So this is going to be plus $4.50. So f of x is equal to x to the 4th. Then I have to add these correctly. It's going to give me 43 minus 43x squared plus 450. All right. So when I have these, I have an imaginary root. The conjugate is also one of the roots. So one of the ones that's not given to you is negative 1 plus 3i. There's actually 3 roots there. So it's going to give me f of x equals x plus 3 times x minus negative 1 minus 3i times x minus negative 1 plus 3i. Then I'm going to multiply. I am not going to distribute this first, like big fat no, because then that gives me 3 terms in here instead of 2, and you want to multiply with just the 2 for sure. Okay, so when I do this, this is going to give me, I'm going to leave this x plus 3 out front here. To get x plus 3, I'm going to put a bracket here. So I'm going to multiply x times x, that's x squared. Then I'm going to do the outside 2, so x times this right here, so it's going to be a negative x times negative 1 plus 3i. And then x times this right here, so it's going to be negative x times negative 1 minus 3i. And then multiply these two together, then this is going to be plus negative 1 minus 3i times negative 1 plus 3i. So then I'll clean this up a little bit. This gives me, saw that x plus 3 out front, right? So then in here I have left x squared, and then I'm going to go ahead and distribute this. This is going to give me a positive x minus 3ix, and then this gives me a positive x plus 3ix, and then plus, now this is a difference of squares here. So I'm going to get negative 1 squared minus 3i squared. So let's think about what's happening with these real quick. Negative 1 squared is just going to be 1. Then 3i squared is going to be 3 squared is 9. I squared is negative 1. So minus a negative 9 is going to give me plus 9. That's what happens right there with those. So then I can clean this stuff up in here. Still have this x plus 3 out front. So I get x plus 3 times. Then I get x squared. I use that one. Then I get plus x, so that's plus 2x. Then I have minus 3ix plus those 0 out. And then I have plus 10, because it's 1 plus 9. So now I multiply these two together. So I'm going to distribute this x into all of these. This gives me x cubed plus 2x squared plus 10x. Distribute the 3 plus 3x squared plus 6x plus 30. And then I can clean all this up. This gives me x cubed. Got that one taken care of. These two give me plus 5x squared. This gives me plus 16x plus 30. That equals f of x. Whole lot of places there for mistakes with signs and whatnot. So make sure you can read your own work and it's done in an organized fashion. I mean, we're not all going to have neat handwriting, but we should still be able to read our own stuff and be able to keep up with it and keep it organized. All right. So next thing here, we are going to solve the inequality and graph our answers on a number line and write using interval notation. All right, so the first thing I need to do is get everything over to the one side. So this is going to give me x cubed minus 4x squared minus 37x plus 40 is less than or equal to 0. All right, so then I have 4 terms here, so I'd like to factor by grouping. Well, that's not going to happen because 37 is the prime number and I can't factor. So if I can't factor, I can't put this in the quadratic formula because it's not a quadratic, and I can't just guess it, randomly try and make up math and factor it. Here's where we look for our possibilities. Okay, so in order to get our possibilities to factor, it's the factors of the constant term over the leading coefficient. So this is 1, so that's nice. So my possibilities here are plus or minus 1, plus or minus 2. 3 is not going to work. 4 works, plus or minus 4. 5 works. Then 8, 10, 20, 40. So then I've got to do synthetic division. Start with 1. This gives me 1, negative 4, negative 37, 40. Bring down my 1, 1, negative 3, negative 3, negative 40, negative 40. Oh, it is just phenomenal when the first one works, right? So what we have here then is f of x equals, this is my 0, so that's x minus 1, times what this is left down here, x squared minus 3x minus 40. Then I would like to factor that. That does factor. So this gives me x minus 1 times, I put f of x equals, but I really want, in the end, I want this to be less than or equal to 0. Then this is going to be x and x. So 2 numbers that multiply to give me 40, they're going to be 8 and 5, and I need the 8 to be negative and this to be positive. So this is what I'm going to use, and I want this to be less than or equal to 0. Okay, so this is what I'm using to get my number line stuff done, right? So here's my number line. On my number line, let's see, my x's are, I'll write this out, negative 5, 1, and 8. So those are the things that go on here. Negative 5, 1, and 8. So then I test. So we'll put in a negative 6. If I substitute negative 6 in here, it's going to give me negative, negative, negative. So negative, negative, negative makes this negative overall. I can substitute in a 0 here. 0 will give me negative, negative, positive, so that's positive overall. Substitute in a 2, give me positive, negative, positive, that's negative overall. Substitute in 9, positive, 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 that's positive overall. So this is negative, positive, negative, positive. And because of this, I want this to be less than or equal to 0. Then these are closed circles on here, which I should have put on there from the beginning. And I want it to be negative, so it's these pieces right here. So I'm supposed to write my answer in interval notation. I'm going from negative infinity to negative 5. Never include infinity. I am including negative 5 because it's a closed circle. And that's a union with 1, 2, 8. And, oh. Okay, that's right. There we go. Alrighty. The next one. This is going to be rational, so I got to get them all to one side of the inequality sign first. So I'm going to subtract this from both sides. So I'm going to get 7 over x plus 3 minus 6 over x plus 2. Okay, and that's going to be less than or equal to 0. All right, so I'm going to make this, that's like it's a negative 6 there. My least common denominator is going to be x plus 3 times x minus 2. So I need to multiply this one by x plus 2. So it'll be 7 times x plus 2. And then this one times x plus 3, so minus 6 times x plus 3. So that's going to equal 7x plus 14 minus 6x minus 18 all over x plus 3 times x minus 2. Then I clean that up some more, and I'm going to get x minus 4 over x plus 3 times x minus 2. and that is going to be less than or equal to 0, because I can't lose the fact that I have a inequality here. This is what I'm using in my inequality. Oh, shoot, I keep writing -2, +2, +2, +2. Glad I caught that. So my zeros here are going to be, so these are my zeros. Because here for rationals, come on board. Oh, Lordy, there we go. My zeros are going to be just 4. My asymptotes are x equals -2 and x equals -3. So on my number line, here's my number line, I'm going to put -2, -3, and 4. And when I do that, the asymptotes always get open circles, and then the 0 gets a closed circle because of what's right there. So then I test it. I can put in, oh, I put these in the wrong order. Dang it. I really do know what I'm doing. This should be -3. That should be -2. That would make more sense. All right, so I'm going to substitute in a -4. -4 in the numerator will give me a negative, and then negative, negative, so it's negative overall. Then if I substitute in like a -2.5, that'll give me negative, positive, negative. Okay, I just got interrupted, so I don't remember the last thing I said. But negative, positive, negative, that makes this positive overall. Then between -2 and 4, I can substitute in 0. So this will give me negative, positive, positive. That's negative overall. And then I can substitute in a 5, positive, 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 positive overall. All right, so this is negative, positive, negative, positive. And what I want, let's see, we want this to be less than or equal to 0. So again, we want the negative parts of this. So we can go from -infinity to -3. Now this is an open circle because it was an asymptote. So open, open. And then from -2 to 4. Okay, we do not include the -2 because it was an asymptote. We do include the 4 because it was a 0. All right, next one. We're going to find all the zeros, and then it says, and given, I should say, and give the complete factorization of the function. So here on this first one here. Now, could I come up with my possibilities and do synthetic division? Absolutely, but the best thing for you to do is only do that when you can't factor. So always try to factor first. This is a 4th degree polynomial, but it's still a trinomial, and so if this is 4 and this is 2, then I can treat it like a quadratic if it actually factors, which it does. All right, so this is going to be, I factor it, I'm going to get an x squared and an x squared. All right, so 4 times 18 is 72, and the signs have to be different, right? And this would have to be positive 18 and a negative 4. But together that would give me that positive 14. So there you go. That's factored right there. Then I can, this is a difference of squares, so I can factor that again. F of x equals x squared plus 18 times x plus 2 times x minus 2. That is right. That is completely factored as far as real numbers are concerned. That is the bare minimum of the complete factorization you need to have. But the whole point of this is for us to actually get any irrational or imaginary answers as well. So then I have to find my zeros. So when I do this, this is x equals 2. This is x equals -2. Here x squared would equal a negative 18. So x equals plus or minus the square root of negative 18. That negative is going to come out like an I, or as an I, and then I can also simplify it. So this is going to be plus or minus 3i squared root of 2. 3i square root of 2. There's that x right there. So here are my zeros, right? So my zeros here are plus or minus 2 and plus or minus 3i square root of 2. So that is my, that's all of my zeros. So it says find all zeros, not find all real zeros. So find all the zeros, then the complete factorization. This was as much as we can do with our factoring skills, but now I do have still this x plus 2 times x minus 2. But then I have these zeros as well, so this is times x plus 3i square root of 2 and x minus 3i square root of 2. And this is the actual complete factorization. Okay. So then on this next one, we always want to try and factor, but I cannot factor because I'd have to factor by grouping here, and in order for me to get these to match, I'd have to factor this 17 out. Well, 17 does not divide into 36, so this is not going to work. So now I have to do my possibilities. This is 1, which is good news, because then my possibilities are just the factors of, 36. My possibilities. And so this will be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4. 5 doesn't work, plus or minus 6. So then 6 times 6 is 36, so then it's 4 times 9, 3 times 12, 2 times 18, and 1 times 36. Okay, so there are my possibilities. All right, so we will start with 1. Put in my 1. 1 to negative 17, negative 36. Bring down my 1. 1, 3, 3, negative 14, negative 14. Well, that's not going to give me 0, so that doesn't work. So I can go on to negative 1. 1 to negative 17, negative 36. By the way, I need to actually see that you're doing this. Like, for you to just randomly guess the right number to put in, I don't know that I actually believe that. Could that happen every now and then? Yeah, but don't like erase it and start over. Like, the process is the idea here. I need to see that you are trying different things. So bring this 1, negative 1, 1, negative 1, negative 18, 18. Still not going to give me a 0. The actual number doesn't matter. So then I can do 2. 1 to negative 17, negative 36. Bring down my 1, 2, 4, 8, negative 9, negative 18, still not 0. Negative 2. Can do 1 to negative 17, negative 36. So I bring this down. 1, negative 2, 0, 0, negative 17. Oh, getting closer here. Oh, look at that. That's going to give me a positive 34. Still doesn't work. Okay, so then I can try 3. 1 to negative 17, negative 36. Bring down my 1. Gives me 3, 5, 15, negative 2, negative 6. That's a big fat no. Negative 3. 1 to negative 17, negative 36. Bring down my 1, be negative 3, negative 1, 3, negative 14. 3 times 14 is going to be 30, 42. So it's a positive 42, still not 0. So we give 4. I have 1 to negative 17, negative 36. Bring down my 1, give me 4, 6, 24. That's going to be 7, 28, still not 0. Negative 4. 1 to negative 17, negative 36. You can always double check that you're actually using the right numbers. Like maybe it's not working out because I wrote the numbers down wrong, but nope, I'm good. Bring down my 1. It's going to give me negative 4, negative 2. It's going to give me 8. And this will give me negative 9. This gives me 36. Woohoo! We got 0. So here is my first root. So now I have f of x equals x plus 4 times x squared minus 2x minus 9. Okay, so I'm not testing anything else because I've got a quadratic here, and so either I'm going to be able to factor it. If I can't factor it, then I do quadratic formula. I would need two numbers that multiply to give me 9, that subtract to give me 2, and those don't exist. Therefore, I got to do the quadratic formula, right? So this right here I know that this one gives me x equals negative 4, right? Then I'm going to get x equals negative b plus or minus the square root of, okay, hang on, I don't have any room to write. Okay, so I get x equals negative b plus or minus the square root of b squared minus 4 times 1 times a negative 9 all over 2 times 1. So it means I get 2 plus or minus the square root of 4 minus, and then 4 times 9, negative 4 times negative 9 is a positive 36. Oh, dang it. Sorry. Positive 36. I don't know what's wrong with me there. All over 2. So then that equals 2 plus or minus the square root of 40 all over 2. I cannot just cancel these 2's out. Big fat no. But I can simplify this square root. This simplifies into 2 plus or minus 2 square root of 10 over 2. Now that I can cross it out of both of them, I can reduce each of these by 2. And so that means my x is equal to 1 plus or minus the square root of 10. So here's 2 of my zeros. Here's this other one. Don't forget about that guy. Right? So I'm supposed to find all the zeros and do the complete factorization. All right, well, here are my x's. They are negative 4 and 1 plus or minus the square root of 10. Then the complete factorization looks like this. X equals, this will be x plus 4 times x minus, because it's always x minus the 0. Just like this is x minus a negative 4. So x minus, and then I get 1 plus the square root of 10. And then x minus 1 minus the square root of 10. And just leave it. Don't distribute anything else. You are done. Get that and that. Those are both parts of your answer. Okay? Sometimes you have to test a lot of them, but you got to show me they're actually testing a lot of them. Okay. Now it says for each function, for each of the following rational functions, find the discontinuities for the domain. So the first thing we have to do is we have to factor. Okay, and I know I didn't give you tons of room to do these things. Probably should have spaced this a little bit differently. But when I factor this, what this is going to give me, what equal sign over here, this is going to give me x minus 3 times x plus 2 over x plus 2. Okay? So the first thing we do is cancel those out. So since we are reducing something here, that means I have a whole, and the x value for the whole is negative 2. Then I am left with my reduced function of f of x equals x minus 3. So I do not have a denominator there, so there are no vertical asymptotes. The whole then, to get the y value, I substituted in here, so this is going to be negative 5. These are the two things that affect your domain. The domain is always like all real numbers except for whatever's going on over there. So this is the set of all x's such that x cannot equal negative 2. Because there's a hole there. Wouldn't make any sense. All right, so here, this is factored. So again, my domain is going to be based on what goes in here. I don't have any holes because I cannot simplify anything. I've got something in the denominator here, so my vertical asymptote is x equals negative 5. So my domain is a set of all x's such that x cannot equal negative 5. Here I need to factor. So this is going to give me x plus 4 times x minus 4, and then x times x minus 4. So then I can cancel these out. Since I'm canceling those out, I have a whole with an x value of 4. My reduced function is x plus 4 over x. So now I still have something in the denominator. Then I look at the vertical asymptotes. I don't get to pick at the vertical asymptotes from here because you can't be both. Then here x cannot equal 0. Or not x, well, it can't equal 0, but the asymptote is x equals 0. I substitute 4 into here. This 4 plus 4 is 8 over 4 is going to give me 2. So then my domain, it's the set of all x's such that, well, I can't have an x here and I can't have an x here. So x cannot equal 0 or 4. All right, so then here, I'm going to factor. So 3 times x minus 2 over x times x plus 8. Can I simplify anything? No, I cannot. So since I cannot reduce anything, there are no holes. In the denominator, I have 2, that gives me 2 vertical asymptotes. X equals 0 and x equals negative 8. So my domain is a set of all x's such that x cannot equal negative 8 or 0. That's where your domain's coming from. All right, now this space over here I'm probably going to have to use to do some of this work. So for each of these following functions, we want to figure out if we have horizontal or oblique asymptotes. Remember, you cannot have both. So it's one or the other. Can't have both. Or maybe it's none. So the first thing I need to do is decide if it's top heavy, bottom heavy, or tied in degree. And this is tied in degree. So since it is tied in degree, I have a horizontal asymptote. That is the ratio of the leading coefficients. And then this is a none. So then on this one, this is top heavy. So if it's top heavy, it does not have a horizontal asymptote. Okay, that opens the door for an oblique asymptote. And then I would need to divide. I would do synthetic division if I can. I can't because this is x squared, so I have to do long division. So I'm going to do x squared plus 2 divided into x cubed plus 2x squared minus 5. So x goes into x cubed. I'm sorry, x squared goes into x cubed. Oh, look at me. I left off something. You have to leave placeholders in here. See, I didn't have a place to put it because I didn't put my placeholder. That's how I knew I messed that up. All right, so I have x cubed, x squared, then this is going to have to be plus 0x, and then plus, what was it? Or minus 5. Minus 5. Okay, so x squared goes into x cubed, x times. X times x squared is x cubed plus 2x. Then you got to make sure you change the signs on here. So these 0 out, then you're going to get 2x squared minus 2x minus 5. X squared goes into 2x squared a positive 2 times. So this is going to give me 2x squared plus 4. Change the signs, those 0 out, and then you'll have a remainder that is completely irrelevant, and your answer is y equals x plus 2. All right. Then here, this is bottom heavy. Bottom heavy means I have a horizontal asymptote at y equals 0. It's that easy. These are tied in degree, so y equals 4. So this has to be none, and this has to be none. Okay, so then this one here, this is top heavy, which means we do not have a horizontal asymptote. Opens the door for an oblique asymptote, and it is just 1 degree higher. Now, in this one, I can do synthetic division. That's great news. So I'm going to have a negative 5 out here, and then 4, negative 1, and 2. Bring down my 4, and this gives me a negative 20. This is a negative 21, and then this is positive 105, which is completely irrelevant, because this is all I really need here, and this is y equals 4x minus 21. Okay. All right, so then I want to find the x and y intercepts here for the following rational functions. So I need to factor, which I did not give you any room at all to do. Great. So you can use a separate sheet of paper. I, on the other hand, don't really have a place for that. So I guess I'm going to use this space down here. All right, so I'm going to number these 1, 2, and 3 since they're not numbered. And we're just going to pretend like this is not part of this graph here. All right, so let's do number 1. And when I factor that, you get f of x equals, well, in the numerator, I'm going to have x minus 5 times x plus 1 over, and then this is going to be x minus 5 times x plus, nope, x minus 2. Okay. So then what happens here is that these cancel out, which means I have a hole, but it's not asking me that here, but I still need to know that they cancel out, because I cancel them out. This is my reduced function that I'm not going to bother to rewrite, and then this is where I get everything else from, right? So my zeros come from the numerator. My zeros are just -1. My y-intercept, and once I substitute 0 in for each one of these, I'm going to get 0, -1/2. So then let's take 2, and I will factor that one. It's going to give me x minus 3 times x plus 2 over x plus 3. That equals f of x. So I cannot cancel anything out there, which means I have 2 zeros from the numerator. It's going to give me a -2 and a 3. The y-intercept I can easily get from this form, and it's going to be 0, -2. So then this top one up here, I'm sorry, not this top one, this next one, try and factor that. Okay, so here I have, I don't have 2 numbers to multiply to give me 4, that would subtract to give me 1, so I can't factor the numerator. My zeros come from my numerator, from the zeros of the numerator. Just because I can't factor it doesn't mean I don't have any zeros. I could have irrational zeros, or I could have imaginary zeros. Imaginary zeros I don't care about. I can't graph an eye on the coordinate plane that we're graphing. So I'm going to have to do quadratic formula. So x equals -b, be 1 plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So this is going to give me 1 plus or minus the square root of 1 plus 16 all over 2, which is 1 plus or minus the square root of 17 over 2. And I cannot simplify that any. Those are the 2 zeros I get from the numerator, so it is 1 plus or minus the square root of 17 over 2. And then my y-intercept, let's get from there, 0, 4/3. And there you go. Okay. I can fix my line here. I don't want this to get confused with my graph. Okay, so now we're going to graph. Pretty much everything we just did on those other blanks we have to do in order to get our graphs. So the first thing I want to do is factor. Now, can I take the square root of this and double it to get this? Absolutely. So when I factor it, I get 4 over x minus 2 squared. Okay, if you have to go the long way to get there, that's fine. Just make sure that you can get there. The more you understand this, the better off you are, because you can do less work. So we have this. So our domain. Well, do you have any holes? No, we don't have any holes. The only thing that affects your domain are your holes and your vertical asymptotes. Do we have vertical asymptotes? Yes. X equals 2. Which means your domain is a set of all x's such that x cannot equal 2. My roots come from the numerator. There are none. Tangents to your togetherness? Yep. I got to factor with the squared in the denominator, so this gives me togetherness at x equals 2. In behavior, do I have a horizontal asymptote? It is bottom heavy, so that's y equals 0, and this is none. Y-intercept, when I substitute 0 in, or if I can just look at that right there, I'm going to get 0, 1. All right, so on my number line, the things I put on my number line are my zeros, which I don't have any, and my vertical asymptotes, which I do have one at 2. So I can substitute numbers in. If I substitute in a 0, that'll give me positive over positive. It's positive overall. If I substitute in a 3, it's going to give me positive over positive. It's positive overall. So remember, the number line shows us where we can change signs. It doesn't mean that you always do change signs. So this is going to be important for us when we graph. Okay? So I'm going to go and plot things that I know. I know that I have a vertical asymptote at x equals 2, right here. I know I have a horizontal asymptote at y equals 0. And I have a y-intercept at 0, 1. Okay. Now, We can cross horizontal asymptotes, but I don't have to check this one because it's at y equals 0. I know that my graph is positive forever. The entire graph is positive, which means I know I'm not crossing this asymptote because it would have to become negative. Right? And then I know that from negative infinity to 2, it's positive. So the only thing that could be happening would be for it to look like this. And then I know from 2 to infinity it's positive. So it also has to be in here. But I would like to get 1 point here just to make sure I, can think about what's happening. So I could pick 3 or I could pick 4. Let's go with 4. So I'm going to pick a 4. So I want to find f of 4, which is going to equal 4 over 2 squared, which is 1. So I have a point at 4, 1, 2, 4, 1. And I think that's good enough to see that it comes in something like this. Okay. And there is your graph. Okay. So I need a factor. So when I factor this, this is going to give me x plus 5 times x minus 2 over x minus 1. And I have nothing to cancel out, so there is no holes. My roots come from the numerator, that's negative 5 and 2. My vertical asymptotes, x equals 1. These are the two things that affect my domain, so it's the set of all x's such that x cannot equal 1. Then tangent CR togetherness, nope, because I have no factors with an even exponent. It is top heavy, so there is not a horizontal asymptote, but that does open the door for a slant asymptote, and I can use synthetic division here. So I get a 1 out here, and then this is where it's multiplied together. So 1, 3, and negative 10. Bring down my 1, 1, 4, 4, negative 6. So this is where this comes from. Y equals x plus 4. And then my y-intercept, get from this right here, is at 0, 10. So on my number line goes my roots and my asymptotes. So I have a negative 5, 1, and 2. Negative 5, 1, and 2. Then I test things. So I'm going to substitute in a negative 6. Right here, it's going to give me negative, 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 negative overall. Then I can substitute in a 0. That's going to give me positive, negative, negative, positive overall. 1.5 is going to give me positive, negative, positive, negative overall. 3 will give me positive, 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 positive overall. So this is negative, positive, negative, positive. Okay. All right. So let's graph some things on our graph over here. I've got roots at negative 5, 2. I've got a vertical asymptote at x equals 1. Slant asymptote at y equals x plus 4. And a y-intercept at 0, 10. Okay. That is 10, right? 2, 4, 6, 8. Yes. All right, so those are the things that I have. So here's what I know. From negative infinity to negative 5. Oh, I didn't put my roots on there. What is this? Oh, I plotted that point. That's not a point. Good Lord. Don't be like me. All right, I need to plot zeros at negative 5 and at 2, not something at negative 5, 2. So I'm going to go to negative 5. 1, 2, 3, 4, 5. And then 1 and 2. That makes a whole lot more sense. 1, 2, 3, 4, 5. Okay. All right, so now, from negative infinity to negative 5, it's a negative. And then from negative 5 to 1, it's positive. So that makes sense for it to look like this. But I got to figure out whether or not I'm going to cross this asymptote. And so I can take my original function or the reduced function, it doesn't reduce, so I like the fact that it's already all multiplied together. X squared plus 3x minus 10 over x minus 1. I set that equal to the asymptote. That equals x plus 4. Okay. So then, I'm going to multiply both sides by x minus 1, so I get x squared plus 3x minus 10 equals x plus 4 times x minus 1. And then it's going to give me x squared plus 3x minus 10 equals x squared plus 3x minus 4. So then when I start to subtract x squared from both sides, those zero out. Subtract 3x from both sides, those zero out. So I get negative 10 equals negative 4. So that tells me it does not intersect my asymptote. Therefore, it has to look like this. That is the only thing that makes sense. All right, so then from 1 to 2, it is negative. So I know that it's not up here for a couple of reasons. I don't have any togetherness, right? And the other reason is because I have to be from negative from here to here, and then it's positive from 2 to infinity. And I know that I don't intersect the asymptote, so it just looks something like that. Okay, next one. I need to factor. This is going to give me x plus 4 times x minus 1 over x plus 2 times x plus 4. All right, so here I can simplify. Those cancel out, which means I have a whole with an x value of a negative 4. My reduced function is x minus 1 over x plus 2. Okay, so then I substitute this in here. I have to find f of negative 4. It's going to give me negative 5 over negative 2. So it's 5 halves. Right. My roots come from the numerator, so that's a 1. My vertical asymptotes come from the denominator. Then this is where my domain comes from. X can't equal negative 2 or 4. Set of all x's such that x cannot equal negative 2 or 4. Oh, or negative 4. Those really should be in the other order then. I wrote the wrong number. All right, any tangents here, togetherness? That would be a no. They are tied in degree, so I have a horizontal asymptote of 1, and this is none. My y-intercept is going to be at 0, negative 1/2. On my number line, I'm going to put the 1 and the negative 2. So negative 2 and 1. Then I test them. So I can substitute in a negative 3. Negative 3 is going to give me negative over negative, which is positive. And here I can put in a 0, so it's negative, positive, it's negative. Put in a 2, positive, positive, positive. So this is positive, negative, positive. All right, so I'm going to plot some things over here. See if I can plot them correctly this time. I have a hole at negative 4, 5 halves. So 1, 2, 3, 4. 5 halves is basically 2.5. So I'll put a hole there. I have a root at 1. I have a vertical asymptote at x equals negative 2. Horizontal asymptote at y equals 1. And a y-intercept at 0, negative 1/2 right here. Okay. So from negative infinity to negative 2, it's positive. So it's positive, and I have a hole there, so I know I've got to have something up here, but it is possible that it goes below that asymptote, so we're going to have to check that in just a second. And then from negative 2 to 1, it's negative, so I know it's going to have to come up like this. And then from 1 to infinity, it's positive. And again, I got to see if it's going to come up over here, but testing it once will figure all that out for me. So I take my reduced function, which is x minus 1 over x plus 2. I set it equal to my asymptote, which is y equals 1. So then I solve this, so x minus 1 equals x plus 2. When I subtract x from both sides, those zero out, and I get negative 1 equals 2, which is a false statement, which means I'm never going to cross the asymptote. So the only thing that makes sense is to come in like this, and then this has to come in here. Oh, better than that. This has to come in here like that. And there's your graph. All right, next one. This is not factored all the way, so I have to factor. So I get 4 times x plus 1 over x plus 2 times x minus 2. So is this factored all the way? Yes. Do I have any holes? No. My roots come from the numerator, so this is a -1. Vertical asymptote is going to have one at x equals -2 and x equals 2. My domain comes from these two pieces here. So the set of all x is such that x cannot equal, well, there are no holes, but it cannot equal plus or minus 2. All right, so then tangent seer togetherness. No, I do not have anything with an even exponent. Horizontal asymptote, it is bottom heavy, so it is y equals 0. And that means this is none. And my y-intercept is going to be at 0, -1. On my number line, I'm going to go -2, -1, 2, -2, -1, 2. Then I check things, substitute in a -3. -3 would give me negative, negative, negative. That's negative overall. -1.5 is going to give me negative, positive, negative, positive overall. Positive. There we go. Then 0 would give me positive, positive, negative. 3 would give me positive, positive, positive. So this is negative, positive, negative, positive. All right, so now to graph things over here, I have a root at -1, a vertical asymptotes at -2, and at 2, and a horizontal asymptote at y equals 0, and then a y-intercept at 0, -1. Okay, so let's look at our sign chart here. From -infinity to -2, it's negative, so the graph is all down here. And I do not have to check to see if it crosses the asymptote because my asymptote's at y equals 0. If it crosses the asymptote, that means it's going to go positive, and I know it stays negative the whole time. Okay? Then from -2 to -1, it's positive, so it's going to come up and hit here. And then from -1 to 2, it's negative, so it's going to have to go down like this. So I am going to cross the asymptote, but I know exactly where it is because that's on a root. So I'd only have one. I would get an answer, but I only get one. And since it's at 0, I don't have to do it twice. And then from 2 to infinity, it's positive the whole time. Again, I know it's not crossing the asymptote because that would mean it would go negative, and I know it has to stay positive. What I do need, though, are I need points that I could use here. So I think I will pick -3. Little slide chart here. We'll do -3. So if I find f of -3, that's going to give me 4 times a -2 over -1 times -5, and that's going to give me -8 fifths. So I can go to -3, -8 fifths, that's going to be 1 3 fifths, -1 3 fifths, it's about right there. I think that's good to get that part drawn in right there. Then here again, we know that I don't have any togetherness, so it has to start up here. It's got to go through this point, and then we've got to hug the asymptote. We are not crossing a vertical asymptote at all, ever. Then from 2 to infinity, it's positive, so it's up here, but I need a point, so we'll pick 3. And then I can find f of 3. That is going to give me 4 times 4 over 5 times 1. So it's going to give me 16 fifths. So I can go to 1, 2, 3, 16 fifths. So 5 goes into 16 3 times with 1 left over, so it's like 3 1/5. 1, 2, 3 1/5. And I'm right there. And I think that's good enough to get that in there. And there's your graph. All right, last but not least, we got a factor. It's not factored. I don't get to cancel these out. This is going to give me x squared over x plus 1 times x minus 1. Nothing I can reduce here, so there are no holes. Roots come from the from the numerator. Vertical asymptotes come from the denominator. My domain comes from these two pieces here, so it's the set of all x's such that x cannot equal plus or minus 1. Tangency or togetherness. Yes, in the numerator I have a factor that has an even exponent. Numerator gives me tangency, so that's at x equals 0. So I'm going to have a bounce there. These are tied in degree, so this is y equals 1. This is none. And then my y-intercept is at 0, 0. Because if 0 is a root, my y-intercept is 0, 0. On my number line, I'm going to have a -1, a 0, and a 1. Then I test things. -2. So when I put anything I put in the numerator here, it's going to be positive every time. Numerator is positive no matter what. But I substitute in a -2, that's going to give me negative, so that is positive overall. And then like -1/2, okay, this is positive. This would be positive, negative overall. Put in a positive 1/2, so I get positive, negative, so that's negative overall. Substitute in a 2, positive overall. So this is positive, negative, positive. And remember, this shows me here, this is where my bounce is, right? This is not an asymptote, so it's not a togetherness thing. It's where your graph's going to come up and look something like that. Alrighty. So on our graph, let's see what we can put on here. We can put a root at 0. We can put a vertical asymptote at -1 and 1 at 1. And horizontal asymptote at y equals 1. And your y-intercept at 0, 0. Okay. So from -infinity to -1, it is positive. -infinity to -1, it is positive. But maybe it goes below that asymptote. We don't know. From -1 to 0, it's negative, but then it bounces and then it stays negative until 1. And then over here it's positive. So again, I could be crossing my asymptote there. I know I won't cross it in here because this is going to come up and come back down. Actually, I can go ahead and get that part drawn in. And since there's no togetherness, again, I know it has to come right here and right here. But I want to know if I'm going to intercept the asymptote, and then I'm also going to want to find a point or two, possibly. So let's take our function. I'll take the one that's multiplied out. This x squared over x squared minus 1. Set it equal to the asymptote, which is 1. So then I multiply, and I'll get x squared equals x squared minus 1. So when I subtract x squared from both sides, I get 0 equals -1, which is a false statement, so I am not crossing the asymptote. Okay. So, but I do need some points in here, so let's try -2. -2. So let's find f of -2. That's going to give me -2 squared over -2 squared minus 1. So that will give me 4/3. So I go to -2, 1 1/3. I think that's good enough to give me that in there. Then I'm going to we'll do a +2. So f of 2 equals, they'll give me 2 squared over 2 squared minus 1. So once again, that is 4/3. It's not always symmetric like this, but this one is 4/3. So I go to 2 and 1 1/3, and this is what my graph looks like. And that is it. So make sure you know how to test for whether or not you are crossing the asymptote. None of these happened to cross. Well, one of them did, but then we didn't even have to test it. But that you also know how to use your number line to build your graph. That you aren't doing random weird stuff like I saw in that quiz. Please, please learn from your mistakes and do not ever cross a vertical asymptote. Be ready for this test.